Hey everybody, today we'll do another video, and today we will do parallel vectors. I think I went to the basic already using the software in the computer about vectors. When we talk vectors in a space, we talked about vectors in two-dimensional. Vectors can be described in two dimensionals, but also vectors can be described in three dimensionals. And because we do in multivariable calculus, we have to describe vectors also in three-dimensional. For example, if I have something like this, right? So I have just a two-dimensional line like this. And then basically I just have it something like that. It's going to be two-dimensional for now, right? Just to give an example, right? So, right? So if let's say right here, this is x, this is x, this is y, and this of course is negative x, right? But not necessary to write it, right? So x, y, right? So I have a coordinate system or two-dimensional, right? Now, what happened here is the following. So let's say that I have a vector v going like, for example, just a random 2, negative. Okay, so let's say, for example, that vector is equal to 2, right? Do something, right? So let's pick 2v. Actually, u. Let's make this u. U is equal to 2v, right? And vector v, vector v is going in this direction. So let me just make a little arrow going that way. So this is vector u, right? Vector v is going that direction, which is technically just this line right here, right? So this is v, right? Now I have another opposite vector. Let's say, for example, that vector w is equal to negative v, right? So now it's going to reverse. Vector w is going to create that down, which is going to become the arrow coming this way. Actually, just for illustration purposes. So, okay, so that's vector. Vector v is being reversed now. W is coming. W is going towards the direction of negative vector v, and is coming in this direction, right? Now, that is a two-dimensional, right? Two-dimensional. Now, let's see if we have a three-dimensional type, right? A three-dimensional. This is two-dimensional, right? So, let's see if we have three-dimensional, right? So in three-dimensional, we got something like this. Right? And then we have like something like this, right? Now, this right here is up, right? So we have x. Okay. Now we have xy and then we have z, right? I have to know the reverse. This is x, and this should be y, and this should be z, right? So x, y, z, right? Now here I am dealing with three-dimensional type. Why? Because I have this right here, and maybe it would help if I do like a dotted line, right? So this is x, right? This is x going up here, right? But it's because it's three-dimensional. When I look at something that's three-dimensional, I cannot see the other side of that item, right? I'm going to put a dotted line in there, right? The same here. Okay, so that would be z, right? And here will be what? Will be continuation of that will be what? Will be x. I'm sorry, y. Y. Right? So this will be y. Right? So now I have something in three-dimensional. Now, this is the thing, right? So we will see if we do an example of parallel vectors, right? The parallel vectors says that, the definition says that two non-zero vectors, u and v, so two non-zero vectors. If I can get a marker that works better, because this is not cooperating too much with me. So that's much better. Two vectors, two non-zero vectors, right? Two non-zero, because these non-zero vectors, and I will explain that why it's not non-zero. Two non-zero vectors, two non-zero vectors, right? Two non-zero vectors, u and v, u and v are in parallel, if there is some scalar c, such as, if there is some scalar c, it's an if here, so be careful. It's an if. If there is some scalar c, some scalar c such as, some scalar c such as u is equal to, u, vector u is equal to c multiplied by vector v, right? But in the case that, in this case, depending on the orientation of c, depending on the orientation of c is going to change that vector, right? If c is negative, of course, then it's going to go that way. If c is positive, it's going to go that way, right? Now, these are non-zero to non-zero vectors, right? Why? Because vector scalar c, anything I specify what is a scalar, right? Scalar is a unit. A scalar is a unit. A vector has a magnitude, has direction on it. A scalar is just a unit, right? For example, speed, right? A speed is a unit, right? I can say I am going 45 miles per hour, but I am not stating where and what direction I am going. But if I say I'm going 45 miles per hour due north, then I have a direction, right? And I have a magnitude. So based on that, I can have a magnitude, right? Because I can actually have a direction where I'm at point north. Based on that, and in some coordinate system, I might have a magnitude, right? So a scalar is such a unit, right? Velocity, accelerations, those are vectors, right? Vectors. Now, so now let's see what is vector. What are vectors in parallel, right? So, for example, right? For example, it says that in the little graph that I showed before, W was pointing to this way, right? Because it was negative B. That means that produces a negative Z, right? Now let's do an example, right? Example, and let's prove it if they are parallel or not. So, for example, vector vector U is initial, right? So let's say, okay, so let's do this. Let's read it down as the book states it. That way it makes a lot of sense, right? So let's say, for example, that I will do it here. So I just need. So vector W, right? And I have vector V, and I have vector U, and I have vector U going that direction, right? And vector U is nothing but vector U is equal to 2 times vector V, right? Okay, so based on that information, right? So vector U has an initial point. Vector W, has an initial point and terminal point, right? That is the purpose of a vector. Purpose of a vector is like you gotta have a initial point and a terminal point. Let's say, for example, you start at some point in this, velocity starting at 10 miles per hour, right? Final, right? So initial velocity and initial velocity 10 miles per hour, right? You come back, or you go to the final point, and then by the time you reach the final destination, then you were doing 60 miles per hour, right? Now, because the car, when you start a car, you will never start at 60 miles per hour. You need to take that initial velocity and increase it, right? So now, so in that case, you will say final minus initial divided by some time. You will get, or whatever, you will get some average, right? Some average velocity, right? Now, so now this is an example that I'm just trying to state here, right? To understand better these vectors, right? To have a better understanding of it. Right now, let's do this example that is shown on the board. So let's say the vector W has vector example, right? Vector W has an initial point, right? Has an initial point at two, -1, comma, 2, comma, -1, -3. And the final point, and the terminal point is at, in terminal point, we can say that terminal point is -4, 7, 5. Okay, so which of the following vectors are in parallel with W, right? Now, the question is, which of the following vectors, okay, which of the following vectors are in parallel with W. Yes. What of the following vectors are in parallel to W? To vector W? Question mark. Right? Now this is, and then they have two vectors here, right? So in U, vector U. Let me see if I can find a different marker because this is not the best. So U, this is not really helping out. Vector U equal to, vector U is equal to 4, actually no, it's 3, 3, -4, 3, comma, -4, -1, comma, -1. And remember, when we write vectors, we write this little things like that, right? So it's good to recognize that this is a point, this is a vector, right? And the next vector, vector V, in this case, V is equal to 12, 16, 4. 12, comma, -16, comma, 4. So those are two vectors, right? The question is which of those vectors are in parallel, right? Okay? Okay? So now we begin by what? Begin by writing W in component form, right? So that's the first goal. The first goal is to write. I need this space here. Okay, so the first step is to write. Begin by writing, right? We begin by writing. So where's the solution, right? Solution, right? Begin by writing W in component form. W, vector W in component form, right? All right, so, right? That's the first step, right? So, okay, so how we do that? Remember I told you final minus initial, right? Final minus initial, right? So which one is the final, right? Well, the final is this is the initial and this is the final, right? So in this case, what do I have? What do I have of my final? I have a negative 4, 7, and 5, right? So, but this each of these, I want to make sure that you guys understand, maybe have an understanding. This represent Y. This represent, actually, no. This represent X. This represent Y, and this represents Z, right? X, Y, Z. All right. So based on that, I have 2 points, right? X, Y, Z, right? Now, so how do I find the component form of that vector? So W is equal to what? Now I have to do something like that and get my points, right? Where are my points? My points are 4, so it's negative 4, negative 4. That is my X point of the final, right? X final, right? Minus X initial. What is X initial? It's just minus 2, right? Minus 2, right? That is my first X point, right? My first X that I'm trying to find the difference between X. Now, next one is the Y. Well, what is the Y final? This is the Y final is positive 7, right? And this is my final Y, right? So this is my initial Y, right? Which is a negative, right? So what I'm doing here is the following. So in here, I put a comma on it to separate those. And then I said, okay, what is it? It's 7, right? And then I minus, but I have to be careful. Be careful. Why? Because Y is a negative. So I need to take this into account. So I do minus what? Minus 1, right? I got my Y now. I put another comma on it. Now I have a what? 5 and 3, right? Now I have 5 and 3. So 5 and 3, right? So now I have 5 and then minus 3. Okay? And that will And that actually will give it some point, right? That would give it like, a number, right? So I do my x, right? Negative minus a negative, it gives me what? It's giving me what is called a negative. Negative minus a negative. In other words, I am adding two negative numbers, which is get what? 6. Negative 6. Positive, right? I have a positive. This, be careful. Be careful, be careful. Here, you gotta be careful. Just pay attention. Because this one becomes a positive, and this one becomes a positive. Now I'm adding this to this, and change the sign to this, and change the sign to this. So this one becomes what? Becomes a positive, which is what? It's going to be 8. Positive 8, right? Because I have positive 7 plus a positive 1, positive 8, right? Put a comma on it. And then I do my last one. So 5 minus 3 is what? It's 2. And that will be my point, right? My W difference. In other words, that will be the component form of W, right? So W is equal to negative 6, 8, comma 2. Okay, so that's part of it. Now I need to check why W is in parallel with that, right? Why? Which one of the two, right? Which one of these two is W in parallel, right? Okay. Okay. So to do that, what I do is the following, right? So I know that if I do the reverse of, because 3, negative 4, and negative 1, 3, negative 4, negative 1, right? So in this case, so we got that, right? So now because U is 3, negative 4, negative 1, right? Then, with that being said, we can say that okay, let's go with U first. U, right, equal to what? Equal to 3, negative 4, negative 1. Okay, so I want to make sure that I get the brackets right the way that they have it. Okay, so they got something like this, right? So yeah, they still, because they consider that as vector. All right, now, so when I do that, what will make this ahead of this? That will be the question. What will make, okay, how will I make this similar to this, right? Well, think about it. If I do that, if I say that W, if I say that U is equal to U, right? If I say that U is equal to 1/2, negative 1/2 W, let's see. If I say that, right, that means that this negative half will cancel that with a with that what? Positive, right? Now, why? Why? Okay, let's just do so you guys see it. So you actually, so u equal to negative half, right? And I replace in w this one by this one, right? Because that is w. Now 6, 8, and negative and 2, right? Okay. So think about this. For me, the value of c, which is the scalar, the value of c, remember, this is the scalar. So I need to find what is the value of scalar, right? Right? So now look at this. This goes here 3 times. Multiply a negative times a negative is equal to 3. This over here goes 4 times. I'm just doing a step by step. Negative times negative 1 times positive 4 is equal to negative 4, right? Is equal to negative 4. Isn't that what we have here? See? Here, I got this, right? Negative times a negative, give me a positive 3. Positive 3. Negative times a positive, it gives me negative 4, which is negative 8, right? Divided by 2 is 4, but I multiply the negative 1, that would be negative 4, right? That would be negative 4. Now, what is this? So this 2 cancels that with that one, and that becomes 1, but multiplied by that is equal to negative 1. And that's how we end up with the same number, which is what? Which is 3, comma, negative 4, comma, negative 1. Right? So I prove that W is in parallel with U. Right? Why? Because I found the scalar. The scalar number is negative half. Right? Now, this is the scalar, right? So now, let's do, so in the case of V, so we found out that U is in parallel, right? Obviously, U is in parallel, right? And so we proved that U is in parallel. Now, how can we check? How can we check that the scalar C such as, right? So in the case of V, right? V, can we do it, right? So let's check it out. So, okay. So in the case of V, we do that the same, right? So in the case of V, right? So we do the same, right? So in the case of B, 2C, right? Why? Why is 2C? Because to make, that is 4, right? So divided by 4, negative 8, and 2, right? So 2C will make that. So let's see. So yeah, so we proved that really also here the same thing. I mean here negative 8, negative 2, right? So that will make this a positive negative 2, right? So yes, positive 2. That will change a little bit. Okay, so let's prove it. Now, so in this case, we say that the 12, right? Let's say, for example, that you say that 12, that negative, all right, so negative half, 12, negative 16, 4, right? Same thing. Cancel that, right? That's negative 6 again, right? Now this here is 8. That is going to be what? Negative times a negative here is going to be a positive 8, right? And here is going to be a negative, this is going to be 2. It's going to be a 2. But this 2 turns into a negative 2 right there, right? So when I do this, this is nothing but negative 6, comma, 8, and I got negative 2. All right? So we end up with the same thing, right? So now, how do I know that these are indeed, that they are indeed in parallel? If they are indeed in parallel, see, right? So in this case, now let's say, for example, right? So you want to take C as a negative 2, right? Let's say, for example, you want to do 12, right? It's equal to 2C, right? But then, so we had what? We had negative 6, we had 8, we had 2, right? That's what we had. Yes. Okay, so now, how do I find my C's here, right? From that number. Alright, so then, so I said, okay, so I said 12 is equal to 2C, right? 2C. But then to get to C right here, this had to be what? Had to be negative, right? So then C is going to equal negative 6, right? Now, here is going to be what? It's going to be equal to what? To get this, of course, again, it's going to be C is going to be a negative 2C again, right? So I get 16, negative 16 divided by negative 2C, right? And Z is equal to 8, which is that one, right? So, okay, so now 4, so actually, no. Well, yes, I mean, yeah. So and then here the same thing, right? So 2c, so 4 is equal to 2c, and then 2, right? So 2 and then z is equal to 2, right? So that's how you can also prove, right, that is indeed in parallel. So that's how you can find the C's too. It's another method, right? So in this case, we found out that those vectors are in parallel, right? So those two vectors, vector u and vector v, are in parallel with this initial point and this final point of vector w, right? So that's it, guys. That's it for today, and I hope you enjoyed this video. If you enjoyed it, please give me a like, subscribe to the channel. Thank you for watching.